we'll go ahead and get started. All right. Hello, Winston-Salem. So this morning we're going to be talking about migrations, database migrations, and why they're important. And we're going to be using a product called Fluent Migrator. So what we're going to do is we're going to start off kind of following along, and I'll send some instructions into Slack. And we're going to go ahead and create a couple of database migrations against the Scala database, since everybody's familiar with that, kind of see how they work, and then we're going to do some exercises for about an hour. So I'll kind of explain everything as I go. I'm going to post a couple things in Slack right now. Try not to get ahead on this. We're going to follow along, but if you do get behind on anything, you'll have the instructions in Slack to get caught up. So I'm going to take these here. Okay, so the instructions are in Empower Public. This is kind of what we're going to be doing for the next hour or so. Like I said, follow along, but if you get behind, you'll have kind of a breadcrumb path to get caught back up. So if you look in the Empower Public channel, that's kind of what we're going to be doing. All right, so database migrations. I want to talk a little bit about kind of the benefits of migrations, why you would use them, and kind of why they're important, and then the different tools that are out there. So up to this point, we've been kind of creating our database schema sort of manually inside of SQL Server Management Studio, creating tables, creating columns, kind of managing the schema that way, which is fine. And a lot of people do that as sort of a first pass. The things that migrations give you, though, is you can create a schema using code. So you can use your C# skills that you've got and use that to kind of generate your database schema, your tables, your columns, foreign keys, everything, views and indexes, using code. And what that kind of gives you are a couple different benefits. For one thing, they're cross-platform, right? So whenever you decide, okay, I'm going to need a database for this application, generally speaking, up front you have to decide which one do I want, pick all the different technologies and drivers and everything that I want to use for that. One of the benefits with using migrations is that they're cross-platform, right? So the same code that you write to create a table and add those columns can be run against SQL Server, can be run against MySQL or Postgres or most other database out there, Oracle. And that, along with the fact that something in ORM like in Hibernate is kind of database agnostic, you can kind of point it and use that at different databases as well. It allows you to defer decisions about your database selection or even switch to another database, right? Which is kind of nice. It gives you that flexibility. In theory, you could generate an entire schema, that points at SQL Server. Your team could make the decision like, hey, we need to move to MySQL or move into, Visual Studio Core, .NET Core, and we want to be on Linux now, right? So you could take that same batch of migrations and run it against MySQL and have your database up to speed. So in practice, that generally doesn't happen that often, but it's nice to kind of have that flexibility, and it's nice to be able to sort of test. Imagine you're doing a product, a standalone product, right? That gets installed on Windows and Linux. You might have a product that runs against a SQL Server database on Windows and runs against MySQL on Linux, right? And you need to sort of test both of those scenarios. Well, it's nice to kind of keep your schema code in sync so that you can deploy and test against both of those databases. If you had like a standalone, kind of Windows front end type of product. Another nice benefit is you can keep your database schema in sync with your code and source control. So as you're working on different features that require a new table or require changes to a field, different columns, maybe you're changing the data type, as you're writing that code in C#, you can also make a migration that kind of matches it, right? So that way, when you check that into source control, you've got a version of your code that matches a version of your database, right? It kind of keeps those things in sync and lockstep. That's really important when you're dealing with a team of developers, or you have a new developer that comes on board. In theory, they can just download your repository, run migrations, and they've got the same database that you have, at least the same structure, right? They're not going to have the same data, but they would have the same database, boom, like that. Instead of sharing backups and sort of trying to try to keep everybody in sync. It's just an easy way through code, through versioned, source-controlled code to keep things in sync. And the final benefit, and one that I think is fairly important, the most important one really to me, is you can have a repeatable database deployment. So you can have a system that can be rolled back. You could roll back migrations. So you could say a deployment doesn't work well. You push something out to your website, and all of a sudden things go wrong, and you want to kind of roll that deployment back. Well, you could roll that back. You could roll the code back to the latest version, but you can also roll your migrations back to the latest version. So your database kind of goes back to version 1 or whatever. So you can migrate things forward. You can roll them back, and we'll kind of take a look at in the code in a second, kind of how that works. And they can also be used in your continuous integration and deployment scenarios and with those systems. So as you code something up, you check it into source control. Your continuous integration and deployment servers kind of check that code out, put it on your test server in an automated fashion. They can also deploy those migrations and get your database up to speed in an automated fashion, right? So with the click of a button, it's kind of like, boom, your database is up to date. So those are kind of the important things. That's why we do it. And quite frankly, for people that enjoy writing C# more than sort of clicking around in SQL Server Management Studio, you saw how hard it is to add foreign keys, right? You got to kind of drill down into several menus and select a bunch of checkboxes. It's like you'll see with one line of code how you can do the same thing, repeatable, over and over again without having to sort of mess around with that UI. So let's take a look here at how we get this started. So the first thing I want you to do is open SQL Server Management Studio. So SSMS or SQL Server Management Studio, and open that up, and we're going to create a new database. Go ahead and connect into that. We're going to create a new database, and I've already got one here. I'm going to delete this one out. Okay, so we've got our Sakala database here, Sakila. We're going to right-click on Databases up at the top, choose New Database. So right-click on the Databases folder, choose New Database, and then we're going to call this Sakila_migrations. And we'll just take the defaults on the database files and everything. So Sakila_migrations. That's what that should look like. Everybody there? All right. So you click OK, and if you refresh in here, you should see a brand new. We don't need. Okay, so there's a message from Winston-Salem. Do we need data in Sakila Migrations database? No. The point with this is we're going to build the schema up from scratch, and you can't have data until you have schema in there. So we're just building the schema right now with migrations. But good question. So right now you'll see in Sakila you've got all these tables. In Sakila Migrations, it's totally empty, right? So brand new, empty database, no tables. Don't start putting tables in through SQL Server Management Studio, because that's what we're going to do with code. So kind of leave this. All we wanted to do here was create a brand new database and sort of leave it there. So does everybody have that Sequila_migrations database set up? Blank one? Okay, cool. All right, so I will minimize that, kind of leave it there. Our next step is going to be opening Visual Studio Code. So Visual Studio Code. All right, so find that in your programs. Click on that to open it. And what we're going to do here, you noticed I have like a little terminal that popped up. And the way that I got to that, let me close this out. You can do toggle terminal, you can do control and the tick mark, or you can come down here to this little toggle integrated terminal icon down here in the lower right hand corner and click on that, and that will pull up a terminal. And I've got this pointed to a git bash. If you've got it pointed to a regular terminal, it may look a little different, but the idea is that we just want to get a terminal window up here. Does everybody see how to get that open?
How did you open it up with migration?
So you can either click Control and the tick button, Control tick. That'll open it, or you can come down here to this little icon. It says Toggle Integrated Terminal, and click that. So Control plus click, or Control plus single tick, or you can click the little icon in the lower right hand corner there. Okay. All right. So once you've got a terminal open down here, I want you to use your file path and change directory methods to get up to your Empower folder, right? So wherever your local root Empower folder is, let's get to that. So it might be under C. I have it under C Projects Empower. Yours might be under C Empower. But go ahead and CD ... to go up one level, and CD into directories to get into your Empower folder. All right. Everybody in Winston-Salem, let me know if I'm going too slow or too fast. All right. So once you're in your Empower folder. And remember, these directions are in Slack in case you kind of get a step behind. You'll kind of see what we're doing. I want you to make a directory for migration. So mkdir, if you're in the git bash here, make directory migrations. And then I want to change directory into it, so CD migrations. So we're going to hop down into that, and you'll see your path will change. Let's see if I can make this a little bigger. So make a new directory migrations and CD into it. All right, so is everybody there? Yep. Change it from PowerShell to Bash. I think there's a terminal settings. Let me see. I think when you pop it open, let's see. There was a settings in here somewhere. When you click on. Yeah, there should be a little pop-up when you open one that says, you can customize, you can change settings, and if you click on that button, you can pick between whether you want a bash shell. The only reason I pulled up a bash shell is because I've got, I want my git bash commands. I'm a little bit more used to like Linuxy type commands, but you can do this in Windows, just in the Windows regular console or in PowerShell just as easily. All these commands should work the same way. So if everybody's in their, let's see, if everybody's in their migrations folder, then I want you to do a .NET new console. So I'll leave that up there for a second. .NET space new space console. And that's essentially creating a new console app in that migrations folder. And once you do that, I'm going to go ahead and do that. And once that's created, I'm going to do, it should run through and create that folder, and then I'm going to go up here to the main window and say open folder. So file, open folder. And basically you just want to open that Empower folder, that migrations folder that you just made. So I'm going to select that. And you'll see that the only thing that it's created is this program right here. All right, so you should have a migration CS proj and a program file. Yep. Yeah, it's fine. That's fine. Yeah, the question was, does it matter if we have bin? It doesn't matter yet until we build it. That'll kind of show up once we build it. So you should just have a migration CS proj file. This is kind of an empty console application right now. So does everybody see this? All right. So I'm gonna open my terminal back up here now that I've got this opened up, and we're gonna add a couple of things. So we've added our console. Now we need to add a couple of packages, right? We're gonna pull in some NuGet packages for Fluent Migrator. So this is .NET add package Fluent Migrator, and all these steps are in Slack. So .NET add package Fluent Migrator. And that's going to add in kind of the core Fluent Migrator package that we're going to be using. That's the NuGet package that's the core piece of this migrations app.
Should we be installing this recommended C# file extension?
Yes. So great question. It will probably, if this is your first time using Visual Studio Code or this version of it, it may ask you if you want to install a C# extension. Go ahead and do that. Go ahead and install that. That'll give you these nice colors up here. If you're not seeing, if this looks kind of black and white to you, go ahead and install that C# component. It will install, and then you'll have to click a button to reload, and it'll kind of go out of Visual Studio and come back in and kind of reload everything. But that'll give you some nice IntelliSense and everything if you don't already have that in Visual Studio Code. We've been doing Angular stuff in there, so we didn't really need that. But now that we're doing C# in there, like that'd be a good extension to install. Yeah. You can also get to that if you didn't get prompted for the C# extension. You can come over here in Extensions. It's this last icon, the fourth one down, and just do C#. It's this one right here. C# for Visual Studio. And you can search up here for C# and do install. And then it'll install, and then it'll ask you to reload. But that's a good one to have. That's what's giving all of our kind of our colors up here. And to get back to your programs, you just click on Explore at that top icon at the top there. All right, so we've got our first package. We're going to add a couple more here. So this one, I just hit the up key. That's a shortcut to get this back, to get my last statement back, because we're going to kind of add on to it. So if you hit up, you can get that back. Add package Fluent Migrator. This one's going to be called runner. So add package Fluent Migrator.runner. And let's install that. And then we're going to click up again because this one's, our last package is very similar. So now we've got fluentmigrator.runner.sql server with capital S for SQL and capital S for server. So .NET add package fluentmigrator.runner.sql server. We're going to add that as well. All right. So those are the three NuGet packages that we're going to need for that. Fluent Migrator is sort of the core piece. The runner is the piece of code that actually runs the migrations in the background. And then Fluent Migrator Runner SQL Server is the SQL Server specific pieces that talk to SQL Server directly. And since we're running this against SQL Server, that we needed that. You could have fluentmigrator.runner.mysql or .oracle or any other Postgres. There's lots and lots of other databases that it supports. In this case, we're doing SQL Server. All right. So does everybody have all those packages installed? Okay. So at the end, once you've got all the packages installed, let's do a .NET restore. So .NET command again, and then restore, and that's basically going to, now that we've added these NuGet packages, it's going to sort of pull them all down and compile them and make sure that we've kind of got everything ready to go. You saw that little pop-up that came up every time we were installing it that asks you to restore each one. You can kind of do that, or you can just do it all one time at the end, do a .NET restore. This is similar to like npm install. It's like, okay, all the packages that you've kind of got queued up here, it's like, let's get them all and kind of install them. So is everybody good? Everybody got everything? Okay. When Salem, everybody kind of caught up to that point? You got all the commands in Slack to get kind of caught up if you're a step or two behind. All right, so the first thing that we're going to do is work on this program file here. We can, for the time being, I'm going to close down this little terminal just because we don't need it right for a few minutes. And we're going to work on this main program. What this program is going to do is essentially run our migrations. So we're going to change this program to kind of get it set up, kind of add all the plumbing in, and then we're going to create 3 migrations to create 3 different tables against the Sequila database. So the first thing we're going to need to do is add some using statements. So at the top, we're going to add in system.link. We're going to add in fluentmigrator.runner. As you start typing these things, you using, and then you start typing fluent migrate, as you start typing it, it'll suggest it. Just hit tab and then dot, and then start typing a few letters and hit tab and then dot. And we want initialization there. It makes it much faster to type. Microsoft extensions, dependency injection. Let's see, okay, so we got namespace, migrations, this program. Okay, so we've got all of our usings that we need there. We're going to take out this console write line. We're going to actually put a real program in here. And the first thing we're going to do is create a service provider. Okay, so right now, don't worry about this being read right now. We're hooking this up to a method that we haven't created yet. Then we're going to do a using statement, and we're going to create our scope. This is just setting up a couple of make type larger. Yeah, sorry. Let me see how to do that without the magnifier. Does anybody know how in Visual Studio Code to make that bigger? It's probably in settings somewhere, right? Here we go. Font size. What's that? Yeah, Control Plus on this is doing the yeah, it's doing the zoom. Oh, preferences. Okay. Let's see what Control equal. Okay. Oh, nice. Yeah. Thank you. There we go. Cool. Is that a little bit better? Is that a little bit better, Winston-Salem? Let me make this a little smaller over here. There we go. All right. We'll see if that's better. Okay. Cool. All right. So we're going to create our service provider. Create scope. And then we're going to call another method that we haven't written yet to update our database. So this is just kind of this is sort of like one-time plumbing. This is something you would do sort of at the beginning of your, at the beginning creating your application, and then it would be sort of a one-time thing. And then over time, as you added migrations to your system, you would add just the migrations. You don't have to do this kind of stuff every time. There's just getting some plumbing in. All right. All right, so now let's fill out these couple of okay. All right. So I'll try to keep this as much on the screen as possible. Let's go like right there. Try to keep as much on the screen as possible while I do the rest. And all this code will be published in GitHub right after this before we start exercises. So, all right, so this connection string right here, mine is going to be a little bit different. This is where, depending on the name of your database, you're going to change that, kind of like we've been putting it in the settings file. We're going to put it just directly in here for now, but my database is at dot, kind of at yours is going to be something like / SQL or S 2017, either that or E. So this is going to be the kind of the connection string you've been typing all week. Put that right here after server. Yours will differ from mine. Everything else should be the same in this screen, but except for that server name right there. That's where you're going to want to put in your server name. Okay, so let me finish this kind of long, super long thing, and then I'll kind of explain what's going on. Okay, So let me get that up there so everybody can kind of get caught up. Get that there. Okay. Add actor right now, this little add actor, we haven't created this migration yet, so that's going to be red. Don't worry about that. That won't build right now, but we're going to add that in later. Basically, what this is saying is this is wiring up the dependency injector for running these migrations, kind of the wiring up the plumbing. So it's saying add Fluent Migrator core to the service collection, so it knows what to call when it runs migrations, which service to call. And we're going to configure a runner. Add SQL Server just says, hey, we're going to be using SQL Server here. With global connection string just says, okay, connect. Let me pull this over some. I don't know how to get more space there. Let me do that. This says trusted connection equals true. This is basically just saying add SQL Server with this connection string, scan in type of actor assembly for migrations. This basically just says, here's where to look for all of my migrations, right? Here's kind of where to look for these. Here's the project to look for these in. So add actor is going to be the name of one of our migrations, the classes. And so we're putting it there for kind of future use to say, hey migrator, go look in this folder essentially. Go look for these. Go look for our migrations here. Add logging just adds a little bit of logging, and then it's creating the service provider for it. That's kind of the last statement that sort of wraps it up in this service provider. So this is just a little bit of necessary plumbing. Trying to fit this all on one screen here. Let me see if I can. Let's see if I can make this a little bit smaller just for a second. Yeah. All right. Sorry. Make this smaller just for a second so everybody can kind of see this connection string and get caught up. I'll leave that there for a second. But that's all this is doing. This is just telling the migrator where the database is, which one we're going to be using, where our migrations are, and setting up some logging. That's all that's doing here. I'll put this little chunk, put this in Slack before I move on. So I posted that create services method in Slack. Yeah, so Paul's asking, so it's Sequila migrations, not Sequila. Yes, we're starting with that brand new database that we created right here, Sequila _ migrations. See how this has no tables in it? So good question. We are not running against regular Sequila because that's got all the table and schema already in it. We're starting with a Sequila _ migrations database because we're going to kind of build it up to look like Sequila using migrations. That's the goal. Okay. All right. So let me make this larger again. All right. Okay. So the last method we need here is our update database method, and that one's pretty small. So we'll go here. We'll say yes, we want to generate that. I'll try to leave this one below it so everybody can read that. So update database. This is going to take an iService provider, and it's going to pass it to the runner, which will run our migrations for us. So service provider, all right, so this is kind of where the magic happens. This is basically just saying grab from my service provider all that plumbing that we just did enables this, like from my service provider, get me an iMigration runner, right? So you're noticing we're using an interface here, like grab me an iMigration runner, and then just migrate up. There are two methods. There's migrate to, three methods. There's migrate down, which you almost never want to use, which tears down all of your schema back to like an empty database. There's migrate up, which is what you want to use most commonly. And that basically takes your database from its current state and it runs any migrations that it hasn't already run. So I'll show you in the table kind of how it manages that. Once we run these migrations, I'll kind of show you how it manages that. But this is all the plumbing. I'll go ahead and post these couple of methods as well, just to make sure everybody's got what they need. There's the update database method. And there's the main method. Those are in Slack under questions. So those are all three pieces in this program. And the only thing that should be read at this point is this add actor, because we haven't added any migrations yet. So when this program runs, it's going to create sort of the services, going to create our dependency injection framework, and then using scope. Remember we talked about using, right? And when we were doing ADO.NET, using a connection. I want to clean up after the connection and everything. You'll notice we're using here because we're talking to a database. We're creating a sort of a transaction scope, and we're updating the database, and then we want everything to kind of close out cleanly after that. That's why we're using that using statement, so that when the migrations are done, we end that connection and we don't leave any things kind of hanging open or creating any memory leaks. So that's all the plumbing. And now we can get to kind of the fun stuff, the whole point of this. So let's create back in Visual Studio. If you click on the Explorer icon up in the upper right-hand corner, if you don't have this open, let's click somewhere in here, just anywhere in there, and let's create a new folder called Migrations. And this is where we're going to keep our migration files. Normally you would have these kind of versions, right? So like along with your application, you might have a version 1 folder, version 1.2, you know, that kind of thing. And as you go along, you're gonna kind of keep all of your database migrations in a certain version folder that goes along with the versions of your code, the versions of your application. So in our case, we're only going to do a couple. We'll just create this, you know, migrations folder and put them in there. All right. So now let's create our first migration. Let's take a look at what this actually does. Okay. So if you click on the migrations folder and then click on this new file icon, we're going to create a new file here. And what we're going to do is we're going to take today's date and we're going to write it in a certain format so that we know that all of our migrations are always kind of displayed in the correct order. So we want to do 2018 07 using two digits there, 07 18, and then we're going to do 0916. It's like 916 right now. 00. Or no, yeah, that's fine. That's good enough. So it's going to be 2018, 07, 18, 09, 16. It's basically like year, month, day, you know, hour, minute. And the reason why you want to do this is you want to see, remember with other people working on other things, when you merge all this together, you want to see kind of what order people have created their migrations. And they can't overlap, right? So they can't have, you know, if I just called this migration 1, and then somebody else called it migration 1, and they kind of merged it in together, you would have a duplicate. So generally speaking, you want to use something like this that's kind of guaranteed to be unique. We even put the seconds on it usually. So 2018 day, month, day, hour, minutes, and then even seconds if you want to. So this is going to be the name of our file, the beginning of it. and then we're going to call this add_addActor.cs. So kind of today's date with the time, add actor CS. And I'll make this a little bigger so everybody can see the full title. All right, so that's what that's going to look like. And the only thing we need in here is a single using statement. This one's going to be a lot simpler. All we need to do is use Fluent Migrator here. So we'll add our namespace, migrations, and then before we, let's go ahead and create our class, and then we're going to decorate it. So let's create our class. This will be called add actor, and it's going to be, and it's going to, you'll notice that it's inheriting from this class right here, right? This base class of migration. That's where it's going to kind of pull in its capabilities. Okay, and you notice that this doesn't inherit abstract member up and down, right? So it's complaining, hey, you know, it's kind of like an interface. The abstract class is saying, hey, you need to have an up and down method. So we can click on this, we can say implement, and that'll create our up and down methods for us. And actually, I'm going to reorder these because normally you want up in front of down. This kind of makes more sense. So yeah, so the question is, does that control period hotkey? I'm not sure. I just clicked on the little, when it was red, I just clicked on the show fixes the light bulb thing and just said implement. Yeah, and it pushed them in there. I just changed up in front of down because up is what you're normally going to want to be doing. That's kind of like the going forward. Hey, we're building new stuff. Down is going to be the opposite of it, and we'll talk about that in a minute. All right, so this is a base migration. This is what it looks like before you kind of start, before you start playing with it. The two most important things here are that up and down method. Up is what takes your migrations, or up is what takes your current schema and adds things to it or makes changes. And then down has to be the exact opposite. It has to reverse out all your changes. So for everything you do in up, you need to do the opposite in down. And your migration should always work such that when you apply a migration and you have different schema in there and you say down and you roll it back, it should leave it in the same state it was before, right? So we're gonna create our first table here, and you'll see how this works. So the command to do that is create table. And this, you'll see why it's called Fluent Migrations in a minute. This is a Fluent interface. We looked at this when Paul showed us Fluent mappings. Remember the in Hibernate mappings where you're kind of creating a mapping for your entity, and it kind of had a similar syntax where it was like .map, foreign key, whatever, and you kind of created a Fluent interface altogether. This works in a very, very similar way. So you kind of start off with a verb. It's like create. Okay, what do you want to create? I want to create a table that takes a name. And then what do I want to do? I'll probably want to create some columns, right? So with column, and let's give this is actor ID. And you'll notice that we're kind of mapping to, if I pull open Sakila and look at actor, I'll show you kind of what we're going to do. So our goal is to make this table with these columns. Right? So actor ID, first name, last update. Y'all are super familiar with this database by now. And that's kind of what we're doing. But instead of coming in here and clicking and sort of add column and sort of messing around the interface, we're going to do it in code. We're doing the same thing in code here. So essentially we're kind of building it up as a repeatable thing, and then when we run it, it's going to generate it all at once. So then we say, okay, with column as this is where we do our data type, right? So this is going to be an int32. Each one of these is a method, right? So we're kind of chaining these things together, dot, 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 and each one is a method. So with column takes a parameter of the column name. As int32 says, hey, I want to make this an integer. How do you think we might make it a primary key? Primary key, right? Dot primary key. And how might we make this an identity column? Right? Dot identity, right? Yeah, good question. So the question was, does it matter which order you do it in? I don't believe so, as long as the table and with column kind of matters. Obviously, you can't create a column before a table, but these I think you can mix and match. So you could like, do it like that. Whoop, sorry. You could probably do something like that, right? The key is really to kind of make it consistent. And if you think about kind of the way things are laid out in SQL Server, it's like you've got your column name, you've got your data type, then is it a primary key, then it's an identity, maybe it's not nullable. So there's kind of a prescribed sort of order in here that just makes it consistent. So even if you can technically do that, it's a good idea to do them all kind of the same way. So now, what's the next column in the actor table? First name, right? So first name is going to be, and okay, so there's different kinds of strings, right? Somebody tell me in Sequila, what is the first name? What's that data type in there in SQL Server? Like if you're looking at SSMS, if you're looking at this view. Varchar 45. What does that mean? What does varchar mean? Versus in varchar. Do you remember the difference? Right, but the in is kind of like Unicode, right? So there's ANSI, which is varchar, variable characters, right? Which means it can have a variable length up to a certain amount. And then there's in varchar, which is essentially a Unicode version of that, right? So this is varchar, so we're going to say as ANSI string, because it's not a Unicode string for some reason. And we're going to make that 45 because that's the length over here. So first name varchar 45. Now what else? What's a third attribute here? Let me make this a little bigger for Winston. What's the third attribute here on these columns? Yeah, nullability, right? Like whether it's null or not null. So this one is not null. How do you think we do this? Maybe not nullable. Boom. Right. So you can kind of see the pattern here. Last name is going to be the same, right? ANSI string 45, not nullable. And you can see, you can see how fast you can type that out versus going in and kind of clicking on things and sort of messing around in the interface, right? It's a lot quicker once you get used to this, and you have little, snippets that kind of pre-fill things in for you, and you can see how quickly this can go versus a user interface, a Windows interface. Okay, so last update as date time, right? So that's a different data type. So with column name, and then usually data type, and then not nullable, not nullable. You can do with default if you want to put default default values in there, that kind of thing. It's basically got all the functionality that you could do in SQL Server Management Studio, kind of manually clicking on things, you can do in here. All right, so that's it, right? That's our table. That's all we've got. Let me make this a little smaller over here. Okay. So that's it. That's our migration for the actor table, and that'll do it up. Now, remember I said in the down method, what do we need to do? We need to kind of unwind it, right? We need to sort of do the exact opposite. So the exact opposite of create, delete table, actor, right? So the up method kind of creates it all. The down method pulls it back down and deletes it.
So that's kind of like the built-in failsafe.
That's a way that you can roll it back. So the question is the down kind of like a built-in failsafe? It sort of is. Think of it in terms of you've got a certain existing schema. So you have 3 tables, right? Which that's what we're going to build, and then the exercise is going to be building out other tables. So you've got 3 tables, and then somebody creates an add migration to add that table. and they add it up, and you put it in production. It's like, oh, there's a mistake, there's something wrong. Like we need to roll it back. We need to go back to this other version. You can migrate it down, and all of a sudden it's back in that former state, right? And as long as that matches the code, everything should work. Yep.
Why isn't it drop table?
Why isn't the question is why isn't it drop table?
If you're
There's
creating the table didn't exist, doesn't the delete table just remove all the records?
no, it drops it. Drop. Yeah, it doesn't have a. I don't think it has a drop. That's just its word for drop. It's a little bit different from the SQL word.
I got you. So there's two in SQL, right?
Yeah. Yeah. So that leads me to one that question that talking about deletes. There are ways of inserting, updating, and deleting data in here. You have to be really careful with putting data in using migration. Normally, you want your data to go in through your system. The exception to that rule is things like enumerable values or lists, kind of metadata that really isn't going to change at all. That kind of have special meanings to your system. So if you have a list of things that have an ID that might be wired up to an enumeration in your system, sort of key elements that you want to use as lookups, those things you actually should put in via migrations, right? Because they're kind of bound to system functionality. The rest of your core data, like you would never add actors in here using migrations, unless it was for like a test database, right? You wanted to kind of drop everything, add a bunch of actors, and then run some tests on it. You could do that, but for your main database, generally this is for generating schema, tables, foreign keys, indexes, views, those types of things. And you really, if you're adding data to the system using migrations, like stop and think about, make sure you know what you're doing. Yeah.
It's DDL.
DDL, right? Yeah. So this is in the domain of schemas. Yeah. Sorry, I've got some questions here. If y'all see anything in questions, kind of yell them out. Yell them out to me. Pretending to be a student, Ali says, why should I use this instead of writing DDL scripts? This generates, that's a great question. This generates DDL scripts for you. So under the covers, when you're running these migrations, it generates those things for you. There are other migrations systems that take DDL scripts and run them kind of in a numbered way like this. This is just a way to sort of do it in code and make it consistent and make it so you can check things into source control. If you have like a big folder full of DDL scripts, it's like, okay, which one do you run in what order? Like, has somebody already run this one in this database? Like, it doesn't really keep track of, which migrations have been run against this. And we'll take a look once we run this finally. I'll show you once the tables are there, kind of behind the scenes, sort of. There's a special table that it creates, like a version table, where it knows what's been run against it already. So at any given time, it's very safe to run migrate up. It's not going to rerun stuff that's already in there because it keeps track of it internally. So Ali's asking if I need to create a stored procedure or something that isn't a method for Influent Migrator, what will we do? Yeah. And Paul says, what happens if actor already exists in the DB? Okay. If actor already exists in the DB, in theory, if you have been using migrations the whole time, if you start it at the beginning of your project, your migration for creating the actor would have already been run in, and the system will know that that's already been run in it, so it won't rerun it. There are ways you can say if exists. There are ways that you can say, does this already exist, to kind of check if it exists, and then create it only if it exists. To kind of, if you want a second level of safeguard, you can do that. So Ali's saying if I need to create a stored procedure or something that isn't a method, there's always ways of executing SQL. So you could create a execute. Whoa. Enter key kind of got away from me there. Execute. Execute SQL, execute script. You can execute external scripts, right? Like if you had like a view definition or a stored procedure definition like on the file system, you could execute a script which would kind of pull that in, right, as a file. Or you can execute SQL just directly. So I could say, create stored procedure, blah, 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 whatever there, right? And now you have to remember that if I created it here, what would I have to do down here? Delete it, right? And that's the problem is when you're executing sort of SQL scripts or whatever, you always have to be cognizant of whatever I'm doing up above. If it's a custom, I'm creating a stored procedure or it's a custom script of some kind, you have to think, okay, I need to roll this back in the down method. So you would do an execute SQL to drop your stored proc down there. It should be proc, not proc. So good questions. So Scott's asking, how can we scale this for a larger database if we have a database with 100 tables, each with at least 15 columns? Okay, great question. This is another place where migration shines, right? Because imagine if you had a database with 100 tables, and that's honestly a small database. Let's talk 400 tables, right? Which is a real size system. So you have 400 tables. You can imagine going through in SQL Server Management Studio, right-clicking, create table, like typing all that stuff out. It would drive you crazy, right? Now imagine if you created, because this is code, imagine if you created helpers where every table has maybe a primary key of ID. It has a last update table. See this column right here? Well, that's on every table. So couldn't I create a helper that says create standard table, and it puts an ID on it, and it puts a last date update on it, and then it takes a collection of other columns that are just unique to that table. All of a sudden, you're not typing this 300 times. You're not typing that 300 times. You're just doing what's unique to each of those tables, right? So because it's code, you can do all kinds of inheritance. You can override. You can create little helpers that kind of put these things together for you, and you end up doing a lot less work, right? It's kind of like when we created that. You could do that same thing for mapping too. Like in Hibernate mappings, you can do a base mapper with an ID, and all of your other entities just sort of pick that up. All the other mappings just sort of pick that up. So anything you can do to make things more efficient with code, you can do that in here because it's code. You can't really do that. I mean, you could create SQL that generates other SQL, I guess, but it's a lot easier in this, and you certainly couldn't. There really aren't any shortcuts if you're just going into SQL Server Management Studio and kind of clicking around the interface. That you have to do everything if you do it that way. Good question. All right, so we've got our actor migration, and this one's done. I'll leave it up there for a second in case anybody's catching up. And we're going to create the same thing for 2 other tables, and then I'll let y'all go, and you can kind of run with it for a while and create some other stuff. I'll send you an exercise. All right, so we've done actor. Let's add film, because this is a big one. Yeah, and Allie's saying SQL that generates SQL. You will write a lot of that over time. SQL that pulls things out from databases and generates other SQL statements with it. Paul's asking, can you use information schema to assist in big databases? You can. You could if you wanted to. If you already had an existing database and for some reason you wanted to generate migrations from it, you could always, because it's code, you can always read out and sort of generate this. In fact, we do have a generator that we use that will essentially read a database and generate migrations from it and generate models and mappings also from it, from an existing thing if we're taking something over, from another company. But yeah, information schema, you could do that for if you're trying to generate migrations from an existing thing. Yeah, using T4 templates, using that kind of thing, code generation. Yeah, normally this is going to be for either migrations you're going to use either on a greenfield project, so a brand new project, or something that you're taking over from somebody else, and you're going to sort of assume the first migration. You might have one big script. So if you took over a database from somebody and you wanted to use migrations from there on up, you might create one big script. You know how you can right-click on the database and say, create task, like generate script for this database? you might generate all the schema, put that in a file, and use that as your first migration here, and say, all right, this has already been migrated, and then just sort of build up from there using regular migrations. All right, so we've got that one. Let's add our second migration here. Let's do film because that one's big. Film actor is easy. So we'll do. Let's come up here, and remember, I'm posting all this code before exercises. So if you're behind or whatever, you can just you can pull or clone the repo down and have a good starting point. So. All right, so let's add another migration to our folder here. So click on migrations, have that highlighted, and we're going to add a new file. Actually, I'm going to close this program down. Add a new file here, and we're going to call this 2018-07-18, what is it, 90938. All right, so it's 938, and we're going to call this add film. .cs. Okay, so same thing as before. We just need our single Fluent Migrator using statement, and that's all we need there. Add our migration namespace. I forgot one thing. Sorry. Let me go back over to Actor here real quick. We forgot something. I said I was going to go ahead and create the class, and we'll come back and add it later. So the one thing that we forgot here that's super important, this wouldn't have run otherwise, is an attribute telling it that it's a migration. So let me add this in. So what we're going to do with this is we're going to, y'all remember attributes, Y'all remember attributes? It's kind of like remember the HTTP post and HTTP get attributes, little square bracket things. So we're going to add one of those up here at the top. We're going to call it migration. And in the parentheses here, we're going to use, let's see, this is add actor. We're going to use this same little date timestamp thing right here. So we're going to do 2018 07 18 09 16. That was the one we did at 9:16. So you'll see that it's basically adding an attribute. This is essentially a timestamp, and this is the attribute that will help Migrator Fluent Migrator know whether this has been run or not. This is what's actually going to be put in that special table in the database to say, hey, this one got run successfully. And that way, as it's running through, it knows all the ones that's run successfully, and it knows the ones that still needs to run. So that's all that does. And normally you want to use this type of timestamp to kind of keep them super unique. So basically migration attribute, and then just put in the date timestamp for add actor, that part of it. We're going to do the same thing. I'm going to do it in the beginning so I don't forget it. We're going to do the same thing over here. The only difference is this is going to be 180938. Right? So you want the timestamp in the migration attribute to match sort of what we're putting in here. The only reason why we're putting them in the file name is so that they order correctly, right? We can know which one we did in front of the other one, just so these order correctly in the list. In here, they actually make a difference. That's the one that actually gets put in the database. This is the one that has meaning. All right, so we're going to add a public class. Call this add film. You can call these classes whatever you want, but generally, and you can also join migrations together, right? So it doesn't have to be one migration per table. You could say, add, the name of this could be add schema for this particular feature, right? And you could add 3 tables in there, and foreign keys and everything. It's as much stuff as you want in each one. We're just breaking these out to kind of keep it simple, adding each table at a time. I could have done all 3 of these tables. We're going to add in one migration file. It really doesn't matter. You can kind of mix and match. Just to it depends on what makes sense in your situation. All right. So again, we're kind of getting. Close that one out. So we're getting, yeah. Okay, sorry about that. So we're getting this red line again. It's got an error. What is it complaining about here? Doesn't have an up and down method, right? Yeah. So we'll add that in. Move that up there again. Normally I would have like a template. I don't work in Visual Studio Code that much, but normally I would have a template that would just say, you'd right click and say add migration, and it would generate this whole thing with like a timestamp and with the up and down methods, and just sort of be ready to go. If you haven't checked out ReSharper yet as a plugin for the regular Visual Studio, that's something that can do that for you. You can create like little snippets, little shortcuts that generate all kinds of sort of boilerplate code for you, so you don't have to type it every time. All right, so in our up method here, we're going to create a table. Let's name this film, and start adding some columns here. I'm going to get rid of this Explorer window so we can have more space. All right, so first thing is we need to add our primary key, right? So film ID as int32, primary key, identity. Okay. And then we do next column's title. This is just a string again, ANSI string 255. All right, so this one, let me jump over here real quick. I'll come back. Let's look at film and sort of look at what we're doing here. All right, so here's what we're creating. So we've got film, title, we've got a bunch of columns here. But you'll notice the second one, title, is not null. So we're going to put that not nullable in there to kind of enforce that. With column, next one is description. And what data type is that? As string. It looks like that one, yeah, that's text. Release year. All right, so release year is interesting. Release, oh no, sorry, that's still a string. So as ANSI string, that one's going to be 4 characters long. So this next one, language ID, that's an integer, foreign key. And then we get to some down here that are small int and tiny int. So we're going to have to change the data type there. Let's go ahead and add this language ID in here. And I think that one's, yeah, this one's not null. Original language ID. All right, so this rental duration is interesting. This is where it's going to be kind of a different data type. Rental duration, tiny int, so that's going to map to byte there. And then length is going to be as int16. So there's kind of there's a list of, just like there is with mappings and C# data types, kind of the in Hibernate mappings. There are also kind of the different data type methods in here kind of map to SQL Server. Column. All right, so the replacement cost is also a little bit different, right? If we look over here, replacement cost is decimal 52, not null. So the way to do that is as decimal, and you'll notice here I've got an overload with the size and precision, so I can kind of map that exactly as it is in SQL Server, and we'll make that not nullable. So I know there's a lot of typing, but unfortunately there's really no way of getting around. You can think of this as like database design, right? I mean, a lot of times I will design my database in migrations, kind of stare at it for a while and make sure it's what I want before committing it. You kind of have to do that one way or the other. You can do that on paper. You can do that, you still have to kind of think about what your columns are going to be, what your data types are going to be. I usually do that as a migration, as kind of like my whiteboarding or my thinking piece, because that way when I'm done, I just click a button to run it. So it's like, if you're gonna kind of think about it and reason it out, it's like you might as well do it while you're building it up, so that it's runnable when you're done. Maybe one day the AIs will be able to design databases for us, but until then, some form of this is there's no way around it. All right. I think I've got a question here. Okay. Why are language ID and original language ID not byte? Let's see. Oh, yeah, sorry. Language ID, original ID. Yep, good call. Original language ID. Yep, good catch. As byte. Yeah, so it looks like language ID, original language ID, and rental duration are all. Wait a minute. Language ID, tiny int. That's weird. I guess the foreign key of that is a tiny int. That's pretty odd. Usually foreign keys are integers because that limits the size of what they could be. That might be. Let me look in language table. See if that's a. That's true. Okay, yeah, that's a tiny int. Yeah, I guess that's what they assume. Yeah, there's only so many languages in the world. All right, so yeah, so good catch. That should be a byte. Those should both be bytes. All right, and so now what do I need to do at the bottom down here to kind of as the rollback or the reversal? Yep, delete table film. All right, so we got another question here. Okay, so Paul's asking, should language ID and original language ID have the reference by method? We're going to, when we do the cross-reference table, we're going to show how to do foreign keys. On this one, since we're not adding language in, I don't think as part of the exercise, we're just going to leave that off for now, because we haven't created the table that it would be a foreign key to. So just leave that as a byte for now. Scott asked, if you migrated the type incorrectly, would that have thrown an error or just create a migration that had different types? Yeah, it wouldn't know, because again, we have an empty database right now. So if we had migrated the type incorrectly, it would have created it. It would have created it as an int32, and we would have had to create another migration to kind of correct for that. You never want to. The cardinal rule of migrations is you never go back and change them. Right? Once they're done and once they've been run, and once that source code has been checked in and other people might have it, you can't change them, because they have to be. When you migrate up, they have to give you the same result every time. So you can't ever change them. Once you've kind of checked them into source control, that's the last time you can pushed. That's really you can't change anything. You change them by writing another migration that would fix it, right? So if we had pushed that in and these had been integers, I would have to do something like change column or something like that. I'm not sure what the syntax is for it, but in Fluent Migrator, because we actually use a different kind of migration framework. This one's brand new. I just learned it last night. We use a different one that's similar, but you would use something like that. You would say like I want to change this column, change table, change column, and then you would change it to the different type. So you always correct a migration with another migration. Yep.
Yeah, that's on timestamp.
That's why they're timestamped. Yeah, it's like you can't change it. It's sort of like, think about it. It's you're encasing it in carbonite. You're sort of like freezing it, and you know if you make a mistake, on your own machine, you can kind of roll it. You know, if I just ran that, I'd be like, okay, what I would do is I would run the down method. It would delete that film out. I could change this migration, then migrate back up. But if you've checked it in to source control, that means somebody else might get it, and that's it. Once you commit, it's like you can't do it. Good question though, and good catch. So that's our whole film, and then we're gonna
What about foreign keys? Do we do anything with that?
Yep, foreign keys. Yeah, foreign keys. We're about to create a foreign key table that'll join those two together, the actors and films. Yeah, so we'll see what that looks like. So let's create a new migration here. This will be the last one that we'll show. It'll kind of give you an idea of foreign keys, and then we'll open it up to exercises. All right, so let's do. All right, so our final migration will be 2018 07 18 09 54, and this is going to be add film actor.cs. Same thing as before, using Fluent Migrator, namespace. Okay, migration attribute, and we're going to steal that from the name we just typed, 07 18 09 54. All right. So this time our down isn't going to be quite as simple, and our up's not going to be quite as simple, because we're going to do two things. We're going to create a table, and then we're going to create the foreign keys. So the table that we're going to be looking at here is film actor. Very simple table, right? So very few columns. But you'll notice that it doesn't really have a primary key, and it's sort of a pure cross-reference table with the actor ID and film ID, both foreign keys. So it's a cross-reference table that we're building. So do create table, film actor. Okay, so we got film actor with column actor ID, and then we'll put in our other foreign key field. That's film ID. And then it had a little last update table too, a last update column. That is date time. Oh, Okay, so that's our table, and that was easy enough. But now we need to create some foreign keys. So how do you think we start off doing that? We just did a create.table. Same thing, create.foreign key. And here we want to put the name of it in there. I'm just going to kind of do a little naming convention where it's foreign key, film actor, table name, and then the field name, kind of showing where it's going to be, what's going to be pointing to. And then this one, the syntax changes up a little bit. So it's from table. So from table film actor, that's this table. Foreign key column's name is actor ID. And then to table, so this is the, the primary key table. That's going to be actor. And primary column of actor ID. So basically, we're giving that that foreign key a name. That's just going to be what it's called. We're going to say, hey, it's from table, this one, the one that we just made. The foreign key column is actor ID. And what are we pointing to? We're pointing to the actor table whose primary key column is actor ID. So that accomplishes the exact equivalent of y'all opening up SSMS and kind of clicking on that relationship manager and going in and setting all those fields. But in my opinion, it's easier to do. And more repeatable, right? Like you can imagine telling 3 people to do that, to set up a foreign key, and they go into SSMS, and it's like, with all that stuff, it's like likely to not come out well. Oop. All right, so now we need to do one on the other foreign key. Same type of thing. So I'm going to kind of steal this just for time's sake. Give y'all some time to work on this. So I'm going to call this film ID, film actor, film ID, and then this is going to be film ID. So that's going to set up that other foreign key. One nice thing I like about this is with the migration system that we currently use, you have to undo the foreign keys before you delete the table. With Fluent Migrator, I believe you just delete the table and it kind of pulls all the foreign keys with it. It's kind of smart enough to know to get rid of all the foreign keys attached to it, which is nice. With the one that we currently use, you would have to do like a drop foreign key here before you delete the table. So the down stays kind of simple in this one. All right, so we're done with all 3 of our tables, and our cross-reference table with all the foreign keys and everything. So let's give it a go here. If you pop your terminal back open, get that back up and running, we're going to do we're going to actually just run this app. Actually, I don't think we need the, yeah, we don't need the terminal, sorry. Well, we do to see the output, I guess. So if you pop your terminal open, we can kind of take a look at the output and everything. Now make sure, the one thing you want to make sure of is to make sure you have this connection string. Remember this connection string back in program. You want to make sure you've got this set right. Otherwise, it won't run against it. As long as you've got that set right, when we run this, we should see our database show up. I've got a question. All right, so we've got our 3 migrations in here. Let's go up to debug and do start without debugging. That's just gonna kind of run it through. And we should see build and then we should see running transaction, beginning transaction, creating table, committing transaction. So it'll kind of give you like a little running history here of what it did, right, in your debug console. So you'll see here, okay, let's go back up to the top. So migrating, beginning transaction, create table, version info. This will only happen the first time. And we'll look at that in a second. Yep. What's that? Oh, to run? Sorry, to run it, once everything's set, just go up and do, in your debug menu, start without debugging. It won't pop up in the debugger. It's basically just saying run this application. And the application will run the migrations. And then if you look in your debug console, it'll kind of show you this play-by-play. So it's creating a transaction. It's creating this version info table that we'll look at in a minute. It's adding a record in there. It's creating an index on it too. Cool. That's only the first time. You'd only see this the first time where it's creating all that stuff. That's just like the metadata that it uses to keep track of things. Down here is where it really starts. So add actor migrating. You can see our timestamp here. Remember when we put that migration attribute in there with the timestamp? So that's how it keeps track of it. So add actor migrating, beginning transaction, creates the table, committing it. You'll notice that each one, it's creating a transaction and committing it around each migration, right? That's the default behavior. You can change it so that it wraps all the migrations in a transaction and all of them either are successful or fail at once. In this particular mode, the default mode that we're in, each migration runs individually and commits individually in the transaction. So if two of them failed and then one of them, or if two of them were successful and one of them failed, you would only have to work on that last one to get it going. So you can see it's creating our table actor, creating our table film, and creating our table film actor, and creating our foreign keys. So now, if we go back over to our SQL Server Management Studio, go to Sequila Migrations, and do a refresh on tables, you'll notice there's 4 new tables, right? One of which isn't one that we made. So you see actor, film, and kind of all the, see primary keys in here, and we see all the different fields that we made. We can look at the cross-reference table and see, okay, yeah, it's got the 2 foreign keys there. Everything looks right. And now let's look at this version info table. So let's actually select from that. So make sure you're in Sequila Migrations up here in the corner, and let's do a select star from version info. Okay. Now this is the table I was talking about where Fluent Migrator actually keeps the information, kind of keeps track of things, right? Let me make this a little bigger. So it's got your version number. Remember, this is like the timestamp that we put in migrations. It could be anything, but I kind of recommend using this format. Applied on, so it shows when it ran, and then it shows a little description normally, and that's just going to be like the name of your class, or if you put a description in the attribute, it'll show that. So it knows, like if we ran migrations again, it wouldn't add 3 more tables of the same. Well, it couldn't because you can't have tables of the same name, but it wouldn't even try to. It would go through here and say, yep, I've already run that, I've already run that, and I've already run that. Right? Now you can imagine when we start adding migrations to this gets important, right? Because you need to know, the system needs to know kind of where you are, that checkpoint in time, to run only the new things and not worry about things it's already done. So that's what it looks at first. Yep.
So, say we made a mistake, we need to go, we need to do another one.
Yep.
Do we still use create, or do we use update, or is it smart enough to know the difference?
If you made a mistake, like what?
Like we needed to add another column or something.
Okay. So the question is, if we made a mistake, if we needed to add another column like that, which happens all the time, right? Because you're never going to get your, and when you're designing a system from scratch, you're almost never going to get your schema exactly right. So you might create a bunch of tables like, oh, we need a new column. Or you do it right the first time, and a month down the road, your customer comes to you and asks you for an enhancement. That enhancement needs a new column to store data for it, for the new feature. So at that point, you would create a new migration, and you would do like update table or whatever, and add that, and just add that column, right? So you wouldn't like create the table again. You would just do that one little thing you're trying to do, like adding a column, or you might be removing a column, or modifying its data type or something like that, or the nullability of it. So everything is kind of additive, right? Even if you're removing something, your migrate up would be removing something, like removing a column, and then your down would be adding it back. Right? It's like it has to reverse it. So don't think of it as like adding and removing. It's like up and down should be making changes and then reversing them perfectly, so it leaves it in a state like it was before. Yeah. Like you should be able to migrate all the way up, migrate all the way down, and then back up again and have the same state, essentially. Yeah, good question. All right, so does everybody understand kind of what we did? Let me pull this back up. Okay. So ignoring kind of the plumbing in here, kind of getting this up and running. Again, that's a one-time thing. Getting that up and running. Migrations are sort of what we're really kind of focusing on here. Changing our schema using code, adding to it, editing it. Adding columns over time, adding views, adding indexes, stored procedures, everything you can do with Visual Studio. with SQL Server Management Studio, you can do in code. You can create all kinds of helpers to help make you type less, and you can inherit, like if you have tables that have common things, you can sort of inherit from them and that kind of thing, and make it easier on yourself. So any other questions? Yep.
So when you say you can make helpers, can you show us how to do that real quick?
Yeah. So the question was, if can you that we can make helpers. So say I had something, and y'all don't have to do this. I'm gonna erase it, but like I create something like a migration helper class, right? And this would have. I'm gonna steal a couple things here. So I might have a static class that has a public method that says create standard table. And this might take a name and an array of columns or something like that, right? I don't know. I'm gonna kind of just pseudocode this out a little bit. This is
Because like they all have a last name, right? So just set it up so they always have last name.
right. So the idea here would be like you can create since this is just code, you could say create. Let's see, what was our thing called? Create.table. Oh, okay. So I would have to. Well, trying to think of. So the idea would be that imagine, and again, this particular framework is brand new to me. We create helpers in our other one all the time. You would essentially take in like the name of a table, a bunch of columns, and you would do something like this is just, again, this is kind of pseudocode. This is for the idea. You would say create table with name, and then then you could do table with with column ID as int 32, whatever. And do kind of all your common stuff, right? And then you would say like for each column in columns, then you could add kind of the additional columns, right? And then you could say say you had like a standard last update, created at that type of thing. Like you could add in all of your kind of common columns, right? And the only thing you're passing this little helper is the name of the table and the columns that aren't common, right? Only the things that aren't like that. Et cetera, et cetera. It would look something like that. It'd be something similar to that. Yeah, I mean, it's just a way of kind of wrapping up things into kind of all your commonalities in something. Let's see. All right, so we got a question. So in a real application, we'd be migrating to our database in the cloud, not our MPC. Yeah, so you would migrate locally to get your development environment up to date. You would check something into source control, and normally a continuous integration or continuous deployment system would pull that out, run that against your test database automatically, run all your tests and everything, migrate your test database up, and have kind of like a place where your users can come in and sort of test it. And if everything's good there, you would have a push button deploy using your continuous deployment system out to production, where those same migrations would run a third time to get your production database up to speed. So that's the nice thing about it, is once you've got these migrations and you know that they kind of work, you can run them in each, in your local development machine, a test machine, a staging machine, production machine, in all different environments that you have, and they'll all run the same way. Okay. All right, so are there any other questions about migrations? Anything from Winston-Salem? Any other questions at all before we get started on exercises? I'm going to put in a couple of things in the Slack. One of which is a URL for the repository. So let me put this here. And that's kind of what I was working off of. If somebody doesn't have a working sort of copy right now, you can go grab that there. If you do, just go ahead and use that. If you were able to migrate successfully and you have those 3 new tables plus the one that it puts in, just go ahead and use that as the basis for the exercise coming up. So let me put the exercise in here. Also, I'm also going to put some more information about Fluent Migrator in Slack as well. It's kind of got like the a little bit more documentation about all the different features it has. Okay, so Scott's got a question. So far we've only shown how to map foreign keys for many-to-many relationships. Could you show how to map relationships for one-to-many? Yeah, those would be the same. Instead of having 2 foreign keys in one table, you would just have in whichever table you're pointing to a foreign key, you just use that same foreign key. This syntax right here, create foreign key, you could use that for any table that has a foreign key to another one, whether it's a cross-reference or not. Cross-reference table just means it's going to have 2 of them, and the table is meant to to kind of point out to, in this case, actors and films and kind of bring them together. If you had a parent-child relationship, you would just in the child table you would just have a foreign key pointing to the parent table essentially. Yep. Let's see. Okay, so Aaron's asking. Is it possible I missed it? This brings in data and schema. So this is mainly for schema. This is mainly for DDL statements. So things that are going to create tables, indexes, foreign keys, store procedures, like kind of the schema part of the database. The only data that you would run in with migrations would be very particular cases. Like if you had a table that mapped to an enumeration in the system, right? Like you remember those enums in C#? So you might have like, I don't know, days of the week, right? Monday, Tuesday, Wednesday, Thursday, and those might map to, certain other values, in the table, 1, 2, 3, 4, 5. You might put that kind of thing in, something that doesn't really change and is bound to system functionality. You might run those in with a migration, right? And you can do insert statements. You can do really any, you can do updates, deletes, everything with this. But you want to be careful about putting user type data in there, right? Because this is going to get applied everywhere. So if I put in some test data into this migration to run against my development machine, and then I checked it in, that would also get put into test, and it would also get put into production eventually, right? So you don't want anything in a migration that shouldn't end up in production eventually, right? Now, that being said, there are ways of creating, in addition to this migration attribute up here, you can put in, there's another one that's like tags, where you can say, dev only or whatever, and you can have them run only against certain environments, right? So you could have like certain things that ran in your test environment to set up data for your test to run against it. You could have, production might be too big to kind of create an index on or something, so you may only have things run locally, for that. But in general, you don't want to add data except in those certain circumstances where you're creating kind of enum bound tables. That's really kind of where we've done it the most. All right. So if there are no other questions, I'm going to go ahead and post the instructions for the exercise into Slack. And why don't we give that about an hour or so? So maybe 11:20 or something like that. And if anybody else has any questions from Winston-Salem, just post them in Slack, and I'll be happy to answer them. Yeah, so we yeah, so the code that was committed to the Git repository was 13 hours ago. I put that in last night, just sort of like a working copy. It does have those two kind of bugs on a language and original language, so you'll want to change that. Also, if you're cloning from the repo, you'll have to change the connection string, right? So those are the couple things you'll have to change. But that should be a working copy. I mean, I ran that in last night. It created tables. So yeah, I'm not that fast. You got a time machine.
You said there were bytes.
What's that?
You said there were bytes?
Yeah, as byte. Yeah, for language and original language. Yeah, it should just be like as byte. Yeah, I think so. All right. So the exercise is in Empower Public channel in Slack. The idea is starting with this base that you've got. Create the category table, film category, address, city, and country. And then if you get those done and you want extra credit and you finish early, go ahead and add the rest of them, work on the rest of the tables. So the idea is to have a Sequila database and then have that Sequila_migrations database. And as you run these migrations in, you can do them one at a time too. You can create one, run it, and just see the schema